Good morning, students. Okay, students, now we have completed with the unit test 1 syllabus. Your test is completed. Now we are proceeding towards the semester portion. In this, we are going to start with chapter number 1, laws of motion. In this chapter, we are going to study about the motion, concept of distance and displacement, acceleration, Newton's law of motion and related equations. Okay, these are the points we are going to cover in this section. Now, see, before proceeding towards the chapter, just to try to verify the following examples. Can we sense the motion in the following activities? A flight of a bird? Yes, we can see the motion, we can sense the motion in it. A stationary train? No. Leaves flying through air? Yes, motion is sensed in this. And a stone lying on a hill? No. A stone which is stationary or which is not moving, it's not possessing any type of motion. So now we are a little bit clear about the concept of the motion. Now, you have learned that the motion is a relative concept. Okay, we have studied that the motion is a relative concept. It means what? If the position of an object is changing with respect to its surrounding, then it is said to be in motion. If the position of object is changing, then we are saying that the object is in motion. Otherwise, it is said to be at rest. We are then studying the concept of distance and displacement. So now you can underline this definition of distance in your textbook, or you can highlight it. So what is the distance? The distance is the length of the actual path travelled by an object in motion while going from one point to another. Okay, so distance is the length of the actual path travelled by an object in motion when the object is going from one point to another. And what is displacement? Displacement is the minimum distance between the starting and the finishing points. Okay, displacement is the minimum distance between the starting and the finishing points. Then here is the comparison between the distance and the displacement. So what is distance? Distance is defined as length of actual path travelled by an object in motion. Whereas what is displacement? Displacement is defined as the shortest distance between starting and finishing points. Distance is a scalar quantity, displacement is a vector quantity. And the distance values, the values of distance is always positive, whereas the displacement values of displacement can be positive, negative or 0. Okay. So this is something which we have studied regarding the distance and displacement. Remaining we will be looking in the next video. Okay students, now we are going to continue with the next section. Now in this video we are going to study about the speed and velocity. So first of all, what is the speed? The speed is the total distance travelled divided by the time required. Means the how much of particular distance is covered in the particular time. That value gives us the speed of any object. What is velocity? The distance travelled in a particular direction by an object in unit time is called its velocity. Okay, and the displacement that occurred in unit time is called the velocity. Velocity is referred as displacement upon time. Means when we are studying displacement of a certain object with reference to time, then we are studying the velocity of that object. Now there are certain things which we should always remember, that the units of speed and velocity are same. In SI system the unit is meter per second, whereas in the CGS system its unit is centimeter per second. Speed is related to distance while velocity is related to displacement. Now this second point, students, you should be very clear that when I am talking about the distance, okay, so when I want to study about the distance and time, that time I will be studying the concept of speed, and when I'm studying about the velocity and time, that time I'm studying the displacement. Okay, this is certain things which you should always remember that even though their units are same, but as shown in the first slide, speed is equal to distance upon time and velocity is equal to displacement upon time. Now, if the motion is along a straight line, the values of speed and velocity are same, otherwise they can be different. Okay, if the motion is in straight line, if you are moving in a straight line, then it may be possible that the speed and velocity might be same, otherwise it may change. Velocity is the displacement that occurs in unit time. Okay, as I have explained you earlier also, that velocity is displacement upon time. The same it is given in the sentence form, that velocity is the displacement that occurs in the unit time. Now, what will happen? The velocity depends on speed as well as direction, and that velocity changes by. Now, velocity is dependent upon the speed of the object or vehicle, you can say for your convenience. Velocity is dependent upon the speed and the direction, and velocity changes in certain conditions. What are those conditions? Now, first of all, changing the speed while keeping the direction same, means when you are changing the speed and the direction is same, that time you may see that velocity of the object is changed. Changing the direction while keeping the speed same means when you are moving in maybe circular motion, or when you are moving on another direction, okay, but your speed is same, that time also you may observe the change in velocity. And changing in the speed as well as direction means when there is a change in the speed as well as direction, that time we observe that velocity of the object goes on changing. Okay, so these are the certain conditions in which velocity goes on changing. What are the changes observed in the velocity? Now, in the next video we will be continuing with the next segment. By that time, at the end of this video, students, you please don't forget to perform the eye exercises which were shared to you previously only. Students, now we are going to study about the concept of uniform and non-uniform linear motion. Okay, this may be something little bit new to you children, so kindly watch this video as many as time your concept is not becoming clear, and simultaneously try to read the textbook also. Refer the textbook and read the lesson properly and watch the videos. Your concepts will be cleared as the time passes. Now, first of all, just to understand the concept, see children, this table is given in your textbook also. Okay, so now we are going to study about the uniform and non-uniform linear motion. So now this chart is given in your textbook, and it shows the three people are traveling, Amar, Akbar and Anthony, in different cars with different velocities. The distance covered by them during different time intervals are given in the following table. Okay, now see children, when you will refer this table, one thing you will come to know, that all the people are starting at the same time, that is 5 o'clock. Now, initially the distance of each person was 0 at 5 o'clock. At 5:30, Amar has covered the distance 20 km, Akbar has covered the distance of 18 km, and Anthony has covered the distance of 14 km. After that, you will come to know that at 6 o'clock, Amar has covered the distance of 40 km, Akbar has covered the distance of 36 km, and Anthony has covered the distance of 28 km. So here you can say that even in the same time interval, the velocities of three people are different. Then at 6:30, Amar is at 60 km, Akbar is 42 km, and Anthony is also 42 kilometers. Okay, now here you will come to know that there are variations. Okay, variations are occurring in the speed, okay, of the persons traveling in the same time interval. Now, what is the time interval between notings of distance made by Amar, Akbar and Anthony? So the time interval difference is 30 minutes. It is same for all. Now, who has covered equal distance in equal time intervals? Now, if you will see the table which is given there, that time you will come to know that Amar and Anthony, they have covered equal distances in equal time interval. Now, are all the distance covered by Akbar is fixed? Okay, Akbar in the fixed time intervals the same. So no, the distance were fluctuating for Akbar. He has not covered the same distance in same time interval. Now, considering the distances covered by Amar, Akbar and Anthony in the fixed time intervals, what can you say about their speeds? So now when we will study the everything, we will come to know that Amar and Anthony were traveling with uniform speeds. Means their speed was same right from the beginning till the end, while Akbar was traveling with non-uniform speed. Okay, so here this is the something which we got from the table, that Amar and Anthony's their speed was uniform, whereas the speed of Akbar was non-uniform. Now, so if an object covers equal distances in equal time intervals, it is said to be moving with uniform speed. If the object is covering equal distance in equal time interval, we are saying that the object is moving with uniform speed. And if an object covers unequal distances in the equal interval of time, it is said to be moving with non-uniform speed. So now I hope your concept of uniform and non-uniform motion is clear, that if the object is covering unequal distances as given in this slide, then it is called as a non-uniform speed. And if the object is covering equal distances in equal time intervals, it is said to be moving with uniform speed. Okay. Now children, here we have completed the concept of uniform and non-uniform speed. Please go through the textbook, read the passage and watch the video as many times as possible, so that your concept will be more clear. Students, now we are going to study about the concept of acceleration. Okay, now in your textbook this activity is given. Okay, so we have to take 1 meter long plastic tube. We have to cut it lengthwise and give it into 2 halves. Take one of the channel shaped pieces, place one of its end to the ground and hold the other at some height from the ground as shown in figure 1.4. This figure is given in your textbook. Okay, you can read this activity. Then we have to take a small ball and release it from the upper end of the channel. Observe the velocity of the ball as it rolls down along the channel. Is the velocity same at all points? Obviously the velocity is not going to be same at all points. So we have to observe the changes in velocity as it moves from top to bottom, through the middle and to the bottom. Okay, so there will be the change in velocity. It is given. Okay, it is given the change in velocity occurs. Now, so what is the concept of change of velocity related to? Change in velocity is related to the term acceleration. Means how to find the value for acceleration. Acceleration is about change in velocity upon time. Now students, see, if the initial velocity means velocity when the object is starting the motion, it is denoted by the term u. Time is denoted by small t, and the final velocity means velocity at the end of the motion of the object is small v. Okay, so when we want to find out the acceleration, there is a formula. Formula is final velocity minus initial velocity upon time. Therefore I can say a is equal to v minus u upon t, where v is my final velocity, u is my initial velocity and t is the time interval. Now, if the velocity of an object changes during the certain period of time, then it is said to have accelerated motion. An object in motion can have two types of acceleration. Okay, now see, if the velocity is changing throughout the motion, then there is a type of acceleration. There are two types of acceleration. The two types of acceleration we are going to study now. If the velocity changes by equal amounts in equal intervals, the object is said to be in the uniform acceleration. Okay, and if the velocity changes by unequal amounts in equal intervals, the object is said to be in the non-uniform acceleration. Means when there is equal change in equal interval of time, that time it will be the uniform acceleration, and when unequal amounts in equal interval of time, the object is said to be in non-uniform acceleration. Okay, so students, now we have reached to the end of this section. We have just made a concept clear about what is acceleration and types of acceleration. Okay, so acceleration means what? Change in velocity upon time. Okay, and there are two types of acceleration. One is uniform acceleration and second is non-uniform acceleration. Okay, hope children your concept about the uniform and non-uniform acceleration is clear. Kindly go through the video once again, then your concept will be more clear. Children, now we are going to study about the concept of positive, negative and zero acceleration. Okay, now, so we have studied about the uniform and non-uniform acceleration in our previous video. Now we are going to study about the positive, negative and zero acceleration. So children, when the velocity of an object increases, the acceleration is positive. In this case, the acceleration is the direction of the velocity. The acceleration is in the direction of the velocity. Then we are calling it as a positive acceleration. When the velocity of an object decreases with time, it has negative acceleration, and negative acceleration is also called deceleration. Okay, negative acceleration is also called the deceleration, and its direction is opposite to the direction of the velocity. The direction of the negative acceleration is opposite to the direction of the velocity. Now, if the velocity of the object does not change with time, if the velocity is constant with the time, then we are saying it has zero acceleration. Neither it is positive. In the situation when the acceleration neither it is positive nor negative, then we are saying that it is having the concept of the zero acceleration. Now here is the distance time graph for uniform motion. Now if you see the distance, okay, the distance covered in meter is same. In 0 seconds 0, then in 10 seconds 15 meters, 20 seconds 30 meter, 30 seconds 45. Means you can say that it is the graph for uniform motion. Now if you will study this graph for uniform motion on the basis of the chart flown, students, this chart is given in your textbook also. You can refer your textbook for this chart. On basis of this, I have drawn this graph. You will come to know that here you are getting a straight line when you draw the you plot such type of graph. Now, an object in uniform motion covers equal distances in equal intervals. Thus, the graph between the distance and time is a straight line. When we plot a graph, then we will be getting a straight line. Okay. Now, children, you have to study this thing very properly. You have to make your concept very clear about the positive, negative and zero acceleration. Okay, and if an object is in uniform motion and it covers equal distances in equal interval of time, then if you try to plot a graph, the graph will always be a straight line. Okay children, now till now we have studied about the concept of the acceleration, okay, and positive, negative and zero acceleration. Children, kindly read the textbook and go through the video till the time your concept is clear. Remaining we will be looking in the next video, and kindly perform the eye exercises regularly. Students, today we are going to study about the concept of the non-uniform motion. Now in this chapter, laws of motion, previously you have studied the concept of uniform motion. The three person's name was given, and then you have compared that. Okay, previously video you have studied that. Now see, this is the distance time graph for non-uniform motion, means motion which is not uniform, which is varying in different time interval. Now following table shows the distances covered by a bus in equal time intervals. Means if you see the section of time in seconds and distance are given in meters. In 0 minutes the distance is 0, okay, 0 seconds. Now in 5 seconds the distance is 7, in 10 seconds the distance is 12, 15 seconds the distance is 20 meters, 20 seconds the distance is 30 meters, 25 seconds distance is 41 meters covered by a bus. Then again in 30 seconds the bus is covering 50 meters distance, and 35 seconds the bus is covering 58 meters of distance. Now see children, if you compare this with time and distance, is there any similarity? Is bus covering equal distance in equal time interval? Now see, your time interval is in seconds. Okay, so 0, 5, 10, 15, 20, 25, 30, 35. Okay, if bus would have covered, suppose the distance, now first distance is 7 meter, and if it would have gone in this way, now 7, 14, 21, 28. Okay, in this way, if your distances would have gone 35, 42, 49 meters, then you could have understood, okay, the bus is covering equal distance, even if the distance can be 10, 20, 30, 40, 50, 60 meters, multiples of same number. Okay, so that time the distance would have been equal, but here the distance covered by the bus and the time interval. Okay, so in equal time interval the bus is not covering the equal distance, and this means that this bus is having a non-uniform motion. And this is something which I have tried to show, distance and time. Okay, now the distance changes non-uniformly with time, thus the bus is having non-uniform motion. Since the bus is not covering equal areas in equal interval of time, the bus is said to have non-uniform motion. Okay children, now remaining we are going to study in the next session. Children, today we are going to study about the next concept of your science and technology part 1, chapter number 1, and laws of motion. Okay, now today we are going to study with the concept of velocity time graph for uniform velocity. Means now we are going to study little bit about the graphical presentation of the velocity and time. Okay, how we can study whether the velocity and it is having a particular uniform velocity or whether the velocity is non-uniform velocity with the help of a graph. Okay, so that this study technique is also known as a graphical presentation. Now a train is moving with a uniform velocity of 60 km per hour for 5 hours. The velocity time graph for this uniform motion is shown in figure given below. See, this is a graph. Okay, this graph is shown there, and velocity is shown and time is shown. Okay, x-axis 1 centimeter is equal to 1 hour, time is given on the x-axis, and velocity is given on the y-axis, where 1 centimeter is equal to 10 km per hour. Teachers, students, see this, the teacher wants to tell you the scale is given over there. See, one scale is written over there. So this scale represents you the how much area is shown on the graph. Okay, and then with this graph we are having a velocity time graph. Okay, now the train is covering 60 kilometers distance. Okay, means 60 kilometer per hour is the speed of the train, and the distance it is covering, it is the time it is covering, and it is running for 5 hours. Now based on this, certain questions are there. Now with the help of the graph, children, for this, if you want your textbook graph which your teacher has shown you here, graph number 1.7, velocity time graph, this graph is given in your textbook. Kindly refer this graph from your textbook while your teacher is teaching you here the questions and answers. With the help of the graph, how will you determine the distance covered by train between 2 to 4 hours? So if you will refer this graph, okay, so between 2 to 4 hours, how much distance is covered by the train? That is, we can calculate with the help of the graph. So when you will calculate, you will see the graph, so you will come to know that the distance covered by train in between 2 to 4 hours is 120 kilometer. Then, is there any relation between the distance covered by the train between 2 and 4 hours and the area of particular quadrangle in the graph? Yes, there is a relationship. Okay, there is a relationship between the distance covered between the train and 2 and 4 hours. What is the acceleration of the train? Now see children, we have studied about the positive. The train is moving with the, first let me tell you the answer, then I will explain you the concept also. The train is moving with uniform velocity, hence the acceleration of the train is 0. We have studied about the positive acceleration, negative acceleration and the zero acceleration. When any train, children, if you want, you can write it somewhere. It is something which you should know. If you want in your textbook, you can write with your highlighter marker that when an object is moving with uniform velocity, the acceleration of that object or any particular train, or here we have considered the example of a train. So when a train is moving with the uniform velocity, its acceleration is 0. Okay, there is neither positive acceleration, neither negative acceleration. Okay, this thing you should understand, students. Remaining we will be looking in the next video. Now we will be studying, students, the next section, okay, of your science and technology part 1. In the chapter laws of motion, today we are going to study about the velocity time graph for uniform acceleration. Now here we are going to study the concept about the uniform acceleration. The car changes the velocity. The changes in the velocity of a car in specific time intervals are given in the table. This table, children, that is given in your textbook. If you want for more reference, and if I want you all to open your textbook and study simultaneously and go to the table as the time I am teaching you. See children, time is given in second and velocity is given in meter per second. So now if you will see, the time interval is 5, 10, 15, 20, 25, 30, 35. And the velocity is 8, 16, 24, 32, 40, 48. The velocity is constant. If you can say in simple, it is the table of 8. For just your explanation, I am telling you, it can be any velocity, can be of any number, but just for your explanation, I am telling you that the numbers are equal. Okay, it is covering equal distance in equal interval of time. Hence, we are saying that the velocity is uniform. And if you see the line, next to the table, if I plot on x-axis, if I am plotting the time, and on y-axis, if I am plotting the velocity. So the line is coming a straight line. Okay, if I join the plots properly, dots properly, my answer will be a straight line. Okay, now the velocity changes by equal amounts in equal interval of time. Thus this is uniformly accelerated motion. How much velocity changes every 5 minutes? Okay, so in seconds it is given. Okay, in seconds, if you want to convert in 1 second, in your 5 seconds, if your object is covering, your car is covering the distance of 8 meter per second, so every 5 seconds how much it will occur? So that is answer is 480 meter per second. Now second thing you should understand, the second point, if you want you can write it somewhere, you can highlight it. For all uniformly accelerated motion, the velocity time graph is a straight line. Okay, so for explaining this once again, I am going to my graph page, and here you are able to see that there is a straight line because it is uniformly accelerated motion, and for every uniform accelerated motion the graph will be a straight line. Okay, this, though I know you all are having basic knowledge of the graphs and everything, no, so your concept will be more clear. And what is the condition for the non-uniformly accelerated motion? The velocity time graph may have any shape depending on how the acceleration changes with the time. So it is very clear that if uniform accelerated motion is there, the velocity time graph will be a straight line. And if there is a non-uniform, so depending upon the changes, depending upon the frequency of the changes, certain times your graph will be going up, again the line will be, slope will be coming down, again it will go. So there will be a change depending upon the velocity of the changes. Okay, in which case, in the non-uniformly accelerated motion, whereas in uniformly accelerated motion, that velocity time graph is always a straight line. Okay children, please read the textbook, see the videos as much as possible, so your concepts will be more clear. Children, now we are going to move towards the next section of your science and technology part 1, chapter 1, laws of motion. Now children, here we are going to study something which is new to you, and you will be feeling very interesting to study it, I know. We are going to study about the equations of motion using graphical methods. Okay, so now in your previous videos, now we have studied about the graphs, different types of graph. You have studied the graphs of the uniformly accelerated motions. Okay, we have studied in the previous videos. Now we are going to study how to study the equation of motion using graphical method. Now Newton studied the motion of an object and gave set of 3 equations. Okay, on the basis of the motion of the object, your Newton has given the 3 types of motions, and what is there dependent upon these relate, or these shows displacement, velocity, acceleration and time of an object moving along a straight line. So we have to study the displacement. You have already studied the displacement right in the first video. Velocity also you are aware, acceleration also you are aware, and time, you know, time is an important factor when you are studying the motion, because time will be the standard, and with the help of the time only you are able to study the further changes in the motion of the object. Suppose an object is in motion along a straight line and with initial velocity u. Initial velocity u, now here I want to explain you little bit. Now suppose you have boarded your bus from your home to school. I know due to this COVID-19 you are not able to reach to school, but just imagine the time when you were coming every day to school, and when you were, most of you might be coming from your own vehicle, your parents' vehicle, or your school bus. But imagine that in a vehicle if you are coming, so the initial velocity when you sat in that vehicle and the velocity of that vehicle when you are reaching the school, so your initial velocity is denoted by the English alphabet small u, and your final velocity is denoted by the English alphabet small v, and the time taken for you to reach the school is denoted by English alphabet small t. Okay, acceleration is denoted by English alphabet small a, and displacement is also denoted by English alphabet small s. Okay children, if you want, this is given in your textbook, but if you want you can pause the video here and note it down somewhere, because next time onwards whenever we will be studying the formulas now, so I will be definitely telling you, but it should click to your also mind that initial velocity is u, final velocity is a, displacement is denoted by s, acceleration by small a, and time by small t. Okay, so Newton has given the 3 equations of motions, which can be written as like this. First is v is equal to u plus at. Now v means what? Yes, very good, it is the final velocity, and u means initial velocity, a means acceleration, very good children, and t means time. So v is equal to u plus at. This relation, this is giving the relation between the velocity and time. Okay, so this will give you the relation between the velocity and time. Then next equation is s. Now s means what? Yes, very good. Means I hope that you all are trying to guess. S means displacement. Very good. So displacement is equal to u means initial velocity, t means time, plus 1/2 at square. A means acceleration and t square means again time square. So this is the relationship between displacement and the time. So what is the relationship? Once again, what is the equation? Once again we will say S is equal to ut plus 1/2 at square. This will give you the relationship between the displacement and the time. And v means final velocity, u means initial velocity, a means acceleration, and s means displacement. So v square is equal to u square plus 2as. This will give you the relationship between displacement and velocity. Okay children, these three formulas you will be requiring throughout the solving of the sessions for the numericals. Kindly go through the formula and try to learn it as much as possible, understand, as well as you have to keep it mind in very properly. Okay children, remaining we will be studying in the next video. Okay children, now we are going to proceed with our next session. We are going to start with our equation describing the relation between velocity and the time. Now we are going to study the relation between the velocity and the time. Okay, now that which is the equation, you have to once again watch first the previous video, then you will be understanding that which is the equation which is describing the relation between velocity and time. I am definitely going to tell you by the end of this video, but first I want you all to once again watch the previous video and the last, when I have explained the different equations describing the relation between time and velocity. So which equation will come, you have to note it down somewhere in your notebook. Which is the equation that is describing the relationship between velocity and time? You have to first guess out of the three equations. Okay, now see, this is a graph. Okay, time versus velocity. Okay, this is the graph given of time versus velocity. Now children, what I want you all now, open this graph is given in your textbook. Okay, now you just open your textbook, and as I will explain you from the videos, you refer your textbook so your concept will be more clear. Now see children, the above figure shows the change in the velocity with a time of uniformly accelerated object. The object starts from the point D in the graph with a velocity u. See, the point D is visible to you all. Yes, on yes, above O the time D is given. So D is having the initial velocity u. So initial velocity of the object is u, and that is also represented as OD. Okay children, see, OD, the distance in your graph, OD shows your initial velocity, and simultaneously I just want to say you the next. Okay, that is DC shows you the, OC shows you the final velocity. Now initial velocity of the object is shown by u, that is distance on your y-axis, OD. Final velocity is represented by small v, and that is the distance OC. Time is given, how much time, small t, and it is denoted by OE. See, here OE is showing you the time axis only shown OE. Okay, now acceleration we have studied. Acceleration A is equal to change in velocity upon time. Now for this again I want you all to refer the video which I have made you, given you for the acceleration. In that we have told that acceleration is equal to final velocity minus initial velocity upon time. Okay, so here what is the final velocity? OC, and initial velocity OD divided by time. So we also know that CD is equal to AT. Okay, because OC minus OD is equal to CD. Here you can see OC, C, OC minus OD is equal to CD. Here it is given. Okay. Kindly refer the graph, children, in given your textbook, so it will be more easy to you for you to understand. So therefore CD is equal to 80. If we draw a parallel line to y-axis passing through the point B, you can refer a textbook, then this will cross x-axis in point E. If I draw a line parallel to x-axis passing through D, this will cross BE at point A. Okay, these are the certain parts of the construction. In your geometry, when any theorems will come or any proof will come, as the we are drawing construction part we are having in geometry. Okay, this year you will be having certain constructions and theorems, so your concepts will be becoming clear in that section also. So this is the whole, this slide is showing you about the construction part, what you have to do the construction part for making your further theorem easy, further proof easy. So what you will get from the graph BE, kindly refer the graph, children. BE is equal to AB plus AE. Therefore, V is equal to CD plus OD. And because it is parallel on the other side, you will get AB is equal to CD and AE distance is equal to distance OD. Therefore, V is equal to AT plus U. From equation 1 we have got V is equal to AT plus U, and therefore by rearranging the term I got the value V is equal to U plus AT. This is the first equation of motion. This is the first equation of motion. Yes, children, please refer the video and try to practice this derivation from here, so your concept will be more clear. Okay, children. Good morning, students. Today we are going to start with your next chapter, Science and Technology, part 1. Here we have started with the laws of motion. Now today we are going to proceed towards the next section. Now here we are going to study how to derive. Children, see, this may be something very new to you. Okay, so now before teaching this part, I just want you to first understand how to study this concept. Okay, so for studying the equation describing the relation between the displacement and time, you have to first practice it. First you have to study it, and it is nothing, only the mathematical equations are there. So there is no such matter that you have to be get tensed. Okay, I am not getting this point. Just focus on what your teacher is saying, practice it, you will be able to understand. Now this is the diagram given. Okay, time versus velocity. It is already given in your Science and Technology textbook. Now here what we have to see, suppose an object in uniform acceleration. Okay, object is in uniform acceleration and it has covered the distance t with the time interval t. So from above figure, the distance covered by the object during the time t is given by the area of quadrangle DOEB. So here you are able to see the quadrangle DOEB. Okay, DOEB, you are able to see this. Then so area of quadrangle DOEB means what? Now you will see here DOEB is forming two parts. It is forming you can say rectangle also and a triangle also. So how we will calculate? So S will be the area of quadrangle DOEB. So DOEB will be calculation of two different diagrams, rectangle plus triangle. So area of rectangle DOEA plus area of triangle DAB. So area of rectangle formula you know, L into B. So here I am going to write AO multiplied by OE. Children, you can refer your textbook also. Simultaneously I am teaching you, you refer your textbook also, so you will be able to understand more clearly. So S is the AE multiplied by OE plus 1/2 area of, what is the formula of area of triangle? Half into B into H. So here I am multiplying 1/2 into AB into DA. But we know that AE is equal to U. OE is equal to T and OE is equal to DA is equal to T. Therefore, AB is equal to AT and AB is equal to CD from one equation that you have already proved. Therefore, now only substitution part is there. Only substitution part. So instead of AE, I am going to write U. OE, I am going to write T plus 1/2 plus AB. Instead of AB, I am going to write AT, and instead of DA, I am going to write only T. So now what formula I have got? S is equal to UT plus 1/2 AT square. Okay, this is the formula which I have derived. Children, once again what I want you all to do, that this we have derived the Newton's second equation of motion. Now what we have to do, that for practicing, keep your textbook open, take any one rough notebook, and as your teacher is saying, try to solve it on your own, so your concept will be clear and you will be able to understand it more properly. Remaining we are going to see in the next video. Children, today we are going to proceed towards our next section, and here we are going to study about the third equation of motion. Okay, so first of all, again the same diagram. This diagram is given in your textbook and previous videos also we have explained with the help of this diagram. Now here what we are going to do, so we have seen from the graph in the above figure, then we can determine the distance covered by an object in the time t from the area of the quadrangle DOEB. Now DOEB is a trapezium, so we can use the formula for its area. So therefore S is equal to area of trapezium. Now the formula for area of trapezium is half into sum of length of parallel sides multiplied by distance between the parallel lines. So here I am getting S is equal to 1/2 into OD plus BE into OE, but we know that OD is equal to U, BE is equal to V, and OE is equal to T. So here what I am going to do, just I am going to insert the values. Okay, just I am going to, instead of OD I am going to write U, instead of BE I am going to write V, and instead of OE I am going to write T. But also I have studied previously only that acceleration A is equal to V minus U, final velocity minus initial velocity upon time. So now instead of time, now what I am going to do, I am going to interchange the place of T and A. Okay, so instead of A is equal to V minus U upon T, I am going to write T is equal to V minus U upon A. Now again substituting the value of T in the equation, I am getting S is equal to 1/2 into V plus U multiplied by V minus U. Okay, so U plus V or V plus U. Okay, in addition sequence change can be done, so there is no change. So instead of V plus U, U plus V, I have said V plus U. No matter, in addition the position of the addends can be changed. So here now what I am getting, S is equal to V plus U multiplied by bracket V minus U upon 2A. So now expanding this, multiplying this and transferring the 2 from the denominator to the numerator place, what I am getting now, 2AS is equal to V plus U multiplied by bracket V minus U. Now what is the expansion of A square minus B square? A plus B in bracket multiplied by A minus B. So same, V square minus U square expansion will be V plus U multiplied by V minus U. And now changing the positions, what I am going to get, V square is equal to U square plus 2AS. Now this is the third equation of motion. This is the Newton's third equation of motion. Now children, see, this thing will be something new to you. So once again I just want you to take your rough notebook simultaneously as your teacher is telling you. Try to write in that rough notebook, okay, and practice it, and watch the video again and again. Keep your textbook also open, because the same equation is given in your textbook also. You can refer either your teacher's video or you can refer the textbook, and remaining we are going to see in the next session. Children, now we are going to proceed towards the next part. Here we are going to study about the uniform circular motion. Okay, so now you have observed the second hand of a clock. Okay, now what can you say about its velocity and speed? The speed of the tip is constant, but the direction of its displacement, okay, and therefore the velocity is constantly changing. Okay, so the speed is constant but the direction is continuously changing, and due to the change in the direction there is change in the velocity. As the tip is moving in a circular path, the motion is called uniform circular motion. Means the second hand of a clock, which type of motion it is showing? It is showing the uniform circular motion. It is exhibiting the uniform circular motion. Now, so now here we can define the uniform circular motion in the words that when an object moves with constant speed along a circular path, the motion is called uniform circular motion. Okay, when an object moves with a constant speed along a circular path, the motion is called uniform circular motion. Now certain examples of uniform circular motion we can see. Example, the motion of a stone in a sling, or that of any point on bicycle wheel when they are in motion. Okay, so when a bicycle is moving in uniform motion, or when a sling is attached to a stone, these two objects are showing the uniform circular motion. Okay, so in next videos we are going to study about it in more detail. Okay children, now we are going to start with the uniform circular motion. So now first here it is how to determine the speed. Okay, so if an object moving along a circular path, if radius is r, the time taken to complete the motion is t. Okay, then its speed can be determined by using the formula speed is equal to circumference upon time. Okay, when an object is in circular motion, so here instead of we are having v is equal to speed is equal to distance upon time, we can have circumference upon time. And now here what we can write the formula, v is equal to 2 pi r upon t, where I is the radius of the circle. Okay, so this formula is applicable when the object is in circular motion. Now here we have to study the determining the direction of velocity in uniform circular motion. So here see, okay, here take a circular disc and put a 5 rupee coin at a point along its edge. You have to see this diagram is given in your textbook also. So a circular disc is there, you have to place a 5 rupees coin on a disc. Now make it move around its axis by putting pin through it. Okay, then we have to try to move that disc. Then when the disc is moved at higher speed, the coin will be thrown off. Okay, see here you are able to see that coin is out of the disc. Coin is thrown out of the disc. Okay, now note the direction in which it is thrown out. So if we will try to note the direction, first of all we will come to know that the object is coming out of a disc in a particular direction. Which direction, that I will be telling you after some time. Now repeat the action, placing the coil at different points along the edge in a circle, and observe the direction in which the coin is thrown off. So now what you have to do, you have to place the coin at different edges and you have to just try to note out in which direction the coin is coming out. You will come to know that the coin will be thrown off in the direction of the tangent, which is perpendicular to the radius of a disc. You will be coming the tangent. This you will be studying in circle chapter in geometry. Okay, but still I think so most of you are aware with the term perpendiculars, tangents. Okay, so the coin will be thrown off in the direction of the tangent, which is perpendicular to the radius of the disc. Now, thus, the direction in which it gets thrown off depends on its position at the moment of getting thrown off. Means at which movement it is coming out of the disc, the direction is dependent on that particular movement. Okay. It means that as coin moves along the circular path and the direction, its motion is changing at every point. Obviously, if a coin is moving in a disc, so if it is in circular motion, even the motion is same but the direction is changing at each and every point. Okay. So this we have studied about the uniform circular motion, and when the coin will come out of the disc, that will be in the position of a tangent. Okay. So remaining we are going to study in the next videos. Students, now we are going towards the next section, towards your science and technology part 1 in chapter 1, that is laws of motion. Students, today we are going to study about the solved examples. Now here I am reading one of the first solved example. An athlete is running on a circular track. He runs a distance of 400 meter in 25 seconds. Okay. Before returning to his original position, what is his average speed and velocity? Now here you have to find out the average speed as well as average velocity. First of all, children, try to focus. This is little bit twisted question. Now you will be asking me, ma'am, why it is twisted question? What is they have just asked simply to tell us the speed and velocity. But if you will look towards the question, it says that the person has returned to his original place. Means he was running on a circular track. Initially he covered the distance of 400 meters and he came back to his original position. So if the what is displacement? The difference between the starting and ending point. Okay. So what is the displacement in this condition? The displacement is 0. So obviously you have to now think what will be the average velocity. So the distance traveled is 400 meters. Displacement is 0 as the person is returning to his original position. And total time is 25 seconds. So now what is the average speed? The formula for speed is distance upon time. Total distance covered upon total time taken. So 400 divided by 25. Your answer is 16 meter per second. Now, what will be the average velocity? Average velocity in this condition is 0. Why 0? Because what is the total displacement? Displacement is 0. And if you divide any number by 0, the answer is 0. So in this condition, the average velocity is 0 and the average distance is 16 meter. Average speed is 16 meter per second. Now the next one. An aeroplane taxis on a runway for 30 seconds with an acceleration of 3.2 meter per second square before taking off. How much distance would it have covered on the runway? So here acceleration is given. Just student, now try to focus. What are the quantities known? Now these are the equations which is based on the Newton's laws of motion which you have already studied. So here the value of acceleration is given, time is given, u, initial velocity is not given. Okay, and s means displacement is also not given. So now here what you are supposed to find out, u is 0. Okay, initial velocity is 0 because it is initially at rest. So 0 means nothing. So initial velocity is 0 and displacement we have to find out. Now using the formula, s is equal to ut plus 1/2 at square. U means 0. 0 multiplied by anything will be 0 itself. Okay. So 0 multiplied by 30 plus 1/2 multiplied by 3.2, that is value of acceleration, multiplied by time square, that is 30 square. And if you do the calculation, if you solve it, you will be getting the answer 1440 meter. So the displacement covered by the, or the distance covered by the aeroplane is 1440 meter. Okay. Remaining solved examples we are going to study in the next video. Students, now we are going to study the next solved examples of your chapter first, laws of motion in science and technology part 1. So now here the question goes, a kangaroo can jump 2.5 meter vertically. What must be the initial velocity of the kangaroo? Okay, so a kangaroo is able to jump about the height 2.5 meter vertically. Okay, so now here the given quantities are A. Now children, this A is acceleration due to gravity and its value is 9.8 meter per second square. Then S is the distance how much the kangaroo is trying to jump or how much it is jumping. Okay, that is 2.5 meter. V means final velocity is 0. Initial velocity you have to find out, that is U. So now using these velocities, what are you able to find? Which equation you will be able to derive? So here you are able to derive the equation. You will be supposed to apply the equation v square is equal to u square plus 2as. Now v square is 0. So 0 square is always 0. Okay. So now you will be getting u square plus 2 into minus 9.8. Okay. Into bracket complete 2.5. 2.5 is given already. Now here you will be having a question why negative sign is given. So negative sign is given as the acceleration is against the negative sign is used as the acceleration is in the direction opposite to that of velocity. Means when you will be jumping, your velocity and your acceleration will be in the opposite direction. That's why we are using the negative sign. So substituting the values in the equations, we will be getting 0 is equal to u square minus 49. Now u square, I'll be changing the sides. Okay, so obviously minus 49 will become the 49. Then my value I'll be getting u square is equal to 49. And then if I want to find out the square root of u, so 49's square root is 7. So the kangaroo is having the initial velocity u is equal to 7 meter per second. Okay, this is the explanation of the third example, that how much is the initial velocity of kangaroo when it's jumping 2.5 meter vertically. Then the next example is, a motorboat starts from the rest and moves with uniform acceleration. If it attains the velocity of 15 meters per second in 5 seconds, calculate the acceleration and the distance traveled in the time. So here the initial velocity, the motorboat starts from rest. Rest means what? Initially it is at 0. When you are trying to solve this problem, children, read the questions very keenly. The answer sometime hint is given in the question only, that initial velocity will be 0. Final velocity means what? It is attaining. How much velocity it is gaining till the time it is reaching the certain extent. So its final velocity is 15 meter. How much time? 5 seconds. So now here we have to find out the acceleration and the distance traveled in that time. So acceleration, so you know already, A is equal to first v minus u, final velocity minus initial velocity upon time. Okay, so final velocity is 15. 15 minus 0 upon 5, you are getting the value of acceleration as 3 meter per second square. Then from the second equation of motion, the distance covered will be s is equal to ut plus 1/2 at square. So s is equal to u, instead of u I am putting here 0 because initial velocity was 0. So 0 multiplied by 5 plus 1/2, 3 multiplied by 5 square. So 0 multiplied by 5, I am getting 0. And then 15 square multiplied by 3 divided by 2. So sorry, 5 square. 5 square 25. 25 multiplied by 3, 75. And 75 divided by 2, you are getting answer 37.5 meter. Okay. So this is the distance covered by the boat, by the motorboat. Okay, so in this way you have to study regarding the solved examples and even the mathematical derivations of this chapter. Students, today we are going to start with the next concept. Please look at the videos properly, and simultaneously, if you want, open your textbook also as your teacher is explaining, so your concepts will be more clear from time to time. So today we are going to start with the Newton's first law of motion. Before starting this, let us discuss certain concepts. Okay, now a static object does not move without the application of a force. See, just imagine the chair on which you sit, any cupboard in your home, or any heavy object. Does it moves on its own? Have you ever noticed such? Okay, so whatever answer is there, just let it be in your mind. We will be coming to that answer afterwards. Then the force which is sufficient to lift a book from a table is not sufficient to lift the table. Suppose if you are having a wooden table, imagine the days when you used to come to school, and the weight which you, the force which you require to lift your textbook, science textbook, is it possible for you to lift your table with the same force? Whatever your answer is there, we will be come to that point afterwards. Okay, then fruits on a tree fall down when its branches are shaken. Means when you shake the branches of a tree, the fruits fall down. What is the reason? We have to study on that. And see, have you ever noticed that as soon as you switch off the electric fan, immediately the blades doesn't stop moving? It requires certain time to stop. So what could be the purpose behind that? Okay, now initially our first two questions, that does any object moves on its own? Never. Does the same force we require, do we require the same force to move a textbook and a table? Never. Okay, so these both answers are no. So what could be the reasons? Okay, if we look for the reasons for above examples, we will realize that the objects have an inertia. The objects have an inertia, and your Newton's first law of motion describes this property, and therefore it is called the law of inertia. Okay, so what is the Newton's first law states? Newton's first law states that an object continues to remain at rest or in a state of uniform motion along a straight line unless an external unbalanced force acts on it. This is the Newton's first law of motion. Okay, definition is given in your textbook. You have to learn it as it is given in the textbook. So when an object is at rest or in uniform motion along a straight line, it does not mean there is no force acting on it. Okay, so when an object is in a straight line or in a motion or it at rest, it doesn't mean that object is stationary. It doesn't mean that there is no force on it. But what is there? Actually, there are so many forces acting on it, but they cancel each other, so that the net force is 0. And Newton's first law explains the phenomenon of inertia. What is the inertia? This is something new to you, so that's why here I am explaining it very properly. Inertia is the inability of an object to change its state of motion on its own. Okay, so inertia is the property of object that no object will change its state on its own unless and until an external force is applied. Okay, remaining concepts we will be looking in the next videos. Students, now we are going to study the concept of the Newton's second law of motion. Okay, the effect of one object striking the other object depends upon both the masses of the former object and its velocity. Just imagine when you are playing certain games, when you are hitting two balls at one time. Okay, if two balls are there, 3 or 4 balls in billiards, the way you play. Okay, so imagine such condition when you play such games. Okay, so what happens when one ball strikes the another ball? The mass and velocity of both depends upon the previous ball, its velocity, and mass of the previous ball. Okay, so this we are going to study in Newton's second law of motion. This means that the effect of force depends upon a property related to both mass and velocity of the striking object. Definitely, if any force is applied, it will be, and the object is in motion or you want to set in motion, it will depend upon both as mass as well as velocity of the object which is striking, and this property is termed as momentum, was termed as momentum by the scientist Newton. So now you will understand what is the momentum. Momentum is the property, okay, the property related to both mass and velocity of the striking object. Now momentum is the product of mass and velocity of an object, where momentum, its symbol is capital P, okay, and m is the mass and v is the, you can say, velocity. Now children, here don't get confused, as your teacher has taught you final velocity also and initial velocity also, if you can recall. So then here you will be getting confused, and what is this, which velocity is it final velocity, is it initial velocity? So here when you are studying the momentum, we will be the velocity of the object, and it will be the velocity in which the object is moving. Okay, so this concept, kindly make it clear children. And momentum is a vector quantity. Okay, momentum is a vector quantity, this you should always remember. Remaining part of this Newton's second law of motion we will be discussing in the next videos. Children, now we are going to continue with the next part. Now we are going to continue with our Newton's second law of motion. Now yes, the rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. This is the definition for your Newton's second law of motion. What does it states? That it states that the rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Now you suppose an object is having mass m and initial velocity u. Okay, when the force F is applied in the direction of the velocity for time t, its velocity becomes v. So now here we will be studying how to derive the formula for the Newton's second law of motion. Now children, if you want, okay, I will be telling you, I just want you all to take a notebook and write simultaneously as I am explaining you these points. So the initial momentum of the object is mu, because the mass is m, very good, and the velocity, initial velocity is u. Then its final momentum after time t will be m into v, because v will be the final velocity. Now rate of change of momentum is equal to change in momentum upon time. Okay, so now what we are going to do, how we are going to calculate the change in momentum? We are going to calculate, since c, mass is same, okay, and time is the same. So now we have to do mv minus mu upon t. Okay, so rate of change of momentum will be is equal to mv minus mu upon t. Now m is a common factor, so we are going to remove m outside the bracket, and now what we are getting? We are getting v minus u upon t. Now children, if you remember the previous videos, we have said that v minus u upon t indicates the acceleration. Acceleration means what? Final velocity minus initial velocity upon the time. So here we are getting the value of a. So now what I have got? M is equal to, rate of change of momentum is equal to ma. Now according to Newton's second law of motion, the rate of change of momentum is proportional to the applied force. Okay, we have studied in the previously, only in this video we have studied the definition of the momentum. So therefore I can say that ma is directly proportional to F. But since I want to equalize it, since I want an equal sign, so this directly proportionality sign I have to remove. So what I am going to add? I am going to add the constant. The constant of proportionality is K. Now what I am getting? F is equal to KMA, where constant of proportionality, K is the constant of proportionality and its value is 1. So 1 multiplied by any numbers doesn't make a difference. So instead of K, now I can directly write F is equal to M multiplied by A. Okay children, and this is the derivation of your Newton's law of momentum. Okay, this is how we are deriving the momentum. Children, please once again watch this video and try to write in your notebook as your teacher is explaining you, so your concept will be more clear. Students, now we are going to continue with the Newton's second law of motion. Certain concepts we are going to study in this video. So here we should know that the momentum has magnitude as well as direction, and its direction is same as that of the velocity. Then you should know that in SI system the unit of momentum is kilogram meter per second, while as in CGS the unit of momentum is gram centimeter per second. Okay, this is certain things which you should know about the value of the momentum or units of the momentum in SI and CGS. Once again I am repeating, in SI system unit of momentum is kg meter per second, while as in CGS it is gram centimeter per second. Okay, then now just and try to understand children. Consider two objects having different masses which are initially at rest. Okay, there are two different objects. The masses, consider two balls. Let one ball be small, another iron ball, football, any ball consider. One is smaller one and another is bigger one. When they are at rest, the initial momentum in both the cases is 0. But suppose a force F acts on both for the time t on both the objects, the lighter one will start moving faster than the heavier object. Okay, but from the formula which we have derived, we know that the rate of change of momentum F in both the object is same, and the total change in their momentum will also be same, that is F multiplied by t. Thus we can say that if same force is applied on different objects, the change in the momentum will be same. Okay children, remaining we are going to study in the next video. Kindly read your textbooks so your concepts will be more clear. Students, today we are going to continue with your first chapter, laws of motion, and now we are going to study about the Newton's third law of motion. Now we have previously learned about the force and its effect on an object through Newton's first and second laws of motion. Now we have to study about the force, that in nature force alone cannot act. Okay, the force is reciprocal action between two objects. Reciprocal, I think so you are very well aware. Okay, so forces are always applied in pairs. When an object applies a force to another object, the latter object also simultaneously applies force on the previous object. Hence you can say that force between two objects are always equal and opposite. It is very common. Okay, now what I am trying to tell, suppose if you if you are bouncing a ball towards the ground or towards the wall, so ball is also reflecting back, ball is also coming back, bouncing back. So this is one of the example which you can say that force acts in both the ways, and this idea is expressed in the Newton's third law of motion. And then the force applied by the first object is called action force, while the force applied by the second object on the first is called reaction force. Okay, suppose you are having a football in your hand or basketball in your hand, and if you are bouncing the ball to the ground, so that will be your action force. When the ball will bounce back up, that will be the reaction force. So now what will be the definition of the Newton's third law of motion? The definition to the Newton's third law of motion is that every action force has an equal and opposite reaction force which acts simultaneously. Okay, this definition is given in your textbook also, so you can refer your textbook also for this definition. So this is the definition for your Newton's third law of motion. Then kindly revise this definition, learn it properly, and in exam also if it comes you have to write the same definition. Remaining we will be looking in the next video. Children, today we are going to study about the next concept of your first chapter, laws of motion. We have to study today about the law of conservation of momentum. Okay, now this may be something new to you. Kindly watch this video twice and thrice and even refer your textbook. Okay, simultaneously as you are watching the videos you can keep your textbook open, so you'll be able to understand the concepts more easily as you read and your teacher explains you. So consider an object A is having mass m1 and its initial velocity is u1. As the object B has mass m2 and the initial velocity of the object B is u2. Okay, so now according to formula for the momentum, the initial velocity of A is m1 u1 and the initial velocity of B is m2 and u2. So suppose when these two balls or two objects, okay, for your consideration I will consider that two balls are there, one ball is A, one ball is B. Okay, suppose these two objects collide. Let the force on A due to B be F1. This force will cause acceleration A and its velocity will become V1. So what will be momentum after collision A1? After A object collides, the momentum will be m1 v1. Okay, then if we try to apply, or if we apply Newton's third law of motion, we will come to know that A also exerts an equal force on B but in the opposite direction, and this will cause a change in the momentum of B if its velocity after the collision is v2. So what will be the momentum of B after collision? m2 v2. And if F2 is the force that acts on object B, then F2 is equal to minus F1, and I can say that instead of F2 now I am going to replace it by m2 a2 is equal to minus m1 a1, because we know that F is equal to ma, force is equal to mass into axis, that we have already studied. Now instead of A, here we are replacing A by v2 minus u2 upon t. Okay, in the third step it is written over there. So instead of m2 I will be writing m2 as it is. Instead of a2 I will be writing v2 minus u2 upon t is equal to minus m1 v1 minus u1 upon t, because you know that it is already given A is equal to v minus u upon t. And therefore now if you cancel the t from both the sides, you are going to get the equation m2 is equal, therefore m2 bracket v2 minus u2 bracket complete is equal to minus m1 in bracket v1 minus u1 bracket complete. Okay, so this is about the concept of the momentum we are studying. Therefore if we will try to open the bracket, we will be getting m2 v2 minus m2 u2 is equal to minus m1 v1 plus m1 u1. And if we'll try to write the equal quantities, all the v quantities together, we will be getting the equation m2 v2 plus m1 v1 is equal to m1 u1 plus m2 u2. And here you will be able to understand that magnitude of total final momentum is equal to magnitude of total initial momentum. Okay, this is the law of conservation of momentum we have studied. Okay, remaining we will be looking in the next lecture. Students, now we will be continuing with the law of conservation of momentum. Now see, there are certain concepts related to law of conservation of previously in the previous video we have derived the law of conservation of momentum. Here we are going to study certain other concepts related to that. That first, when no external force acts on two interacting objects, their total momentum remains constant. When there is no external force in the two interacting objects, their total momentum will be remaining constant. It does not change. The momentum is changed after the collision. Once they collide with each other, that time only the momentum gets changed. The momentum gets redistributed between the colliding object. It gets redistributed again both the objects. And the momentum of one of the objects decreases while the momentum of the other object increases. We can say that while two objects collide, the total momentum before collision is equal to the total momentum after the collision. Let us consider the example of a bullet fired from a gun. Okay, when a bullet of mass m1 is fired from a gun of mass m2, its velocity becomes v1 and its momentum becomes m1 v1. Before firing the bullet, both the gun and the bullet are at rest, and hence the total initial momentum is 0. According to above law, the total final momentum will also has to be 0. Thus, forward moving bullet causes gun to move backward after firing. You have mostly seen in the movies also that when a person is firing from a bullet, they are firing the bullet. After the bullet gets out, the gun comes backside. Okay, and this backward motion of a gun is called recoil. Okay, when the gun comes back after the bullet is fired, that is known as a recoil. And the velocity of recoil is v2 is such that m1 v1 plus m2 v2 is equal to 0, or v2 is equal to minus m1 m2 multiplied by v1. This is which we have studied about the law of conservation of momentum. This is about the recoil velocity of a gun. Remaining we will be looking in the next video. Students, now we are going to move towards the next video, and here we are going to study about the solved examples. First solved example is the mass of cannon is 500 kg and its recoil with a speed of 0.25 meter per second. What is the momentum of the cannon? So here we are having mass of the cannon, that is 500 kg, and recoil speed is 0.25. So what will be the momentum? Momentum is equal to mass into velocity. Okay, so when you multiply 500 by 0.25, your answer will be 125 kilogram meter per second. So this is the momentum of the cannon. The next solved example is, student, this is given in your textbook. You can solve from your textbook also as your teacher is explaining, so your concept will be becoming more clear. Next is two balls have masses 50 gram and 100 gram, and they are moving along the same line in the same direction with the velocities of 3 meter per second and 1.5 meter per second respectively. They collide with each other after the collision. The first ball moves with the velocity of 2.5 meter per second. Calculate the velocity of the ball after the collision. So here you have to apply the formula which you have studied in the previous videos. So now first, what is the given section? The given is the mass of the first ball is equal to m1, that is equal to 50 gram, that is equal to 0.05 kilogram. I have already told you when I was teaching you previously, and you have to consider whatever the units they have given, and either in the CGS or in the SI system. So what will be the mass of first ball? 0.05 kilogram, and the second mass of the second ball will be 0.1 kilogram. The initial velocity of the ball will be u1, okay, first ball, and the initial velocity of the second ball will be u2, okay. Final velocity of the first ball will be v1 and final velocity of the second ball will be v2, but we have to calculated. V2 is unknown. So how are we going to calculate? Now, according to law of conservation of momentum, we can say that the total initial momentum is equal to total final momentum. You have to insert the formula. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Now I have written the formula. Now I am going to insert the values. What are the values I am going to insert? 0.05 into 3 plus 0.1 into 1.5 is equal to 0.05 into 2.5 plus 0.1 into V2. Now V2 is already unknown, so we have written it as it is. Then 0.05 into 3, I am getting the answer 0.15. 0.1 into 1.5, I am getting the answer again 0.15 is equal to 0.05 into 2.5, my answer is 0.125 plus 0.1 is the V2. If I will add both the sides 0.15, 0.15, I have got the answer 0.3, and then 0.125 I have kept as it is plus 0.1 into V2. Now what I have done, I have changed the position. 0.1 V2 is equal to 0.3 minus 0.125. 0.3 minus 125, my answer is 0.175, and I divide, if I divide 0.175 by 0.1, my answer is 1.75 meter per second. Okay, so this is the value of my V2, that is the final momentum of the second object. Okay, children, please take your science textbook, keep in front of you. It is very easy, and once you just try to focus it properly, you will be able to understand the concept very properly. Okay, study properly and go through the lesson, read the lesson twice or thrice.